Hi, I am Lily Young from the Telluride High School, and this summer I studied neuroscience at the University of California, Davis. So basically what I studied was the connectome, which is also a synaptic network. So basically it consists of synapses, axons, dendrites, and the soma, which is also the cell body. So what happens is the synapses transmit information throughout the brain via chemical and electrical signals. Basically, the axon of one neuron releases a chemical signal onto the dendrite of another neuron. This signal is turned into an electrical signal and travels through the soma, and then down the axon of another, down the axon right here, and then is transmitted onto the dendrite of the next neuron. So the way I did it was I used serial block electron microscopy, and here's the data. So, next slide. So basically what serial block-based electron microscopy is, it's basically electrons are beamed down onto a subject. In this case it was an owl brain because I was studying the synaptic connections in the owl brain. So the electrons are beamed down and they're reflected back up, and a picture is formed. You can see that on the far side of the screen. And those are the sections, cross sections that are formed from that picture. And here's a picture of the serial block electron microscope. I didn't actually get to do this, but this is the data I used. So basically what I was studying was a toric spine, so that's what we were getting pictures of with the serial block electron microscopy. So basically right here we have a cross section, and I would trace sections of it. So for example, if you can see right up there, that is a cross section of a toric spine. And then on the far side of the screen, you can see that is the fully completed toric spine. So after tracing tons and tons of these cross sections, I was finally able to create that 3D replica of a toric spine. So outside of my internship, I did a lot of fun things. I went kayaking. I got to go to the farmer's market, and I got to bike around Davis. So every day I would bike to my internship, and I would bike from my internship. And then some advice I have for future Pinterns is to ask questions. It's so, so important. I mean, I would have gotten nowhere because I was studying neuroscience and I had never done any classes about neuroscience. The furthest I'd gotten was a biology class. And so I had to ask a ton of questions, and that helped me out so much. It's also important to take initiative because that's what people love to see, especially the people you're interning with. If you're like, I will do this, they will love you because it takes some work off of them, and then it shows how invested you are in your internship. And then it also teaches responsibility. You have to be really responsible for these. I mean, I know I was biking around a city I'd never been in to get to and from my internship, and I had to be responsible. It was basically like being an adult, but not really, but a little bit. It was a little bit like that. And then, next slide. I would like to thank William DeBello. He was who I worked with on the internship, and his wife Mel for taking me kayaking. Love her. And then I would like to thank Parker, who I also worked with on the lab, Sarah Holbrook, the Pintern, the Pinhead Institute, and my host family. Yeah.